Hello students, in this video I will discuss the concept of Turing machines. That is, I will introduce the concept of Turing machines and what are the symbols used in Turing machines and what are the operations that can be performed in the Turing machines. Okay, and then in the upcoming videos I will discuss some very interesting and very important questions of Turing machine. Okay, Turing machine is actually a universal machine, that is a very powerful machine, and it can perform almost all the functions. Okay, so it can calculate things, it can accept things, it can generate strings and so on. Okay, so Turing machine is actually a 7 tuple. So whatever machines we study in Automata, we have to represent all the machines in the form of tuples. So in Turing machine we have 7 tuples. Fine, namely it is capital Q, sigma, delta, then we have a tau here, Q naught, B and F. Okay, so first of all I will explain what these tuples means, and then I will tell you how to read the Turing machine and how the operations are performed in Turing machine. Okay, so in this one we have first one we have it is a Q. What is a Q? Q is actually a finite set of states. That is, like we have Q naught, Q1, Q2, Q3. Whenever we are accepting some string, whenever we are generating any string, we are hopping from one state to another. So that is a finite set of states. So all those states that are there in the Turing machine, that will be included in the capital Q. Okay, so next one is sigma. Sigma is a set of input symbols. Okay, so whatever string we are reading, whatever the elements of that string are, that will be called as an input symbol. So that is a finite set of input symbols. Okay, and this sigma is also a subset of the tau. Now I'll tell you what is a tau, and then I'll tell you what how it is a subset of a tau. Next one, the third one is the tau, this one. Okay, so tau is a finite set of tape symbols. Like, so in this one we have a tape, in a Turing machine we have a tape, and it is a two-way infinite tape. Fine, so in this one, like unlike in PDA where there was a tape and we are reading the tape from the left to the right direction. Okay, so whenever we have to read any string, we start from the left direction and then we move on while pushing the elements into the stack, and finally we end at some final element of the string, and after that we are not able to move back to the previous element of the string. But in this one we have an infinite tape. This infinite tape is divided into infinite number of cells. Fine, so in this one we have infinite number of cells, and in this cell we are actually loading our strings into it. Okay, so this string is read by this read-write head. So we have a read-write head in this one, and this read-write head is capable of performing certain functions. Fine, so what functions? It can read the elements of the tape, plus it can change the elements of the string. Like whenever it is reading this element A, it has the capability to either change it also or write a new element in this one. Fine, so it can read this A and it can even change this A to X. Okay, then again it can read, again it can move forward and it can read this A, and this A again can be changed to say X, and again it can go forward, again read this B and change this B to Y. Fine, so this read-write head is capable of moving on to the right direction, plus it is capable of moving on to the left direction also. So it can go this way also, read the elements, and it can come back also and it can read the elements in the left direction as well. Okay, so whatever elements we are placing on the input string will be called as the tape symbols or the tau. Okay, so whatever the strings elements are, that will be called as the sigma. So in this one the string we have is AABB. So AB will be the sigma in this one, and we are reading this A and changing this A to X, changing this B to Y. So what elements now I have in this one? I have A also, I have B also, I have X also, I have Y also. So all these elements which are being there into the tape will be called as the tau. Now other than this A and B and X and Y, we have some certain special symbols also. Fine, so in this one we have some special symbols as blanks. So all these cells will be filled with several blanks. So in tau what we have? In tau we have this A, we have this X, we have this Y, we have this small b, we have this capital B. So all those elements which are there into the input tape will be called as the tau. That is the third one. Okay. And now come back to the second one. Second one is sigma is a set of input symbols. So input symbols in this one are the string whichever we are reading will be the input symbol. Okay. So in the input symbol we have A and B, and it is saying that sigma is a subset of a tau. Fine. So what is tau? Tau is any element that is there onto the tape, and onto the tape we have this A and B also, and this A and B is the sigma. So sigma is the subset of tau, and this B does not belong to sigma. Fine. So with these blanks, what we have in the input tape, these does not belong to the sigma. The input string cannot be of B, that is blanks. Okay. Now the next one, B, fourth one. So B belongs to tau. So B is actually a tau, is the blank symbol. Okay. Fifth one, fifth is a transition, is a delta. Delta is a transition function, and the transition function says this is your input part, this is your output part. Now what does it say? It says that whenever we are working on to some state, like we are working on state Q0 or Q1, and on that state some input tape symbol is applied. Fine. Like A is applied. Like for example, you can say we have state Q0, and on this state an element is applied, an element is read, like we have read the input symbol A. Now what do we get? We reach on to some state, like we reach on to state Q1, and then what is the operation performed onto the tape? Like in the tape we have A, and we are reading this A. Either we can leave it as A only, or we can change this A to some other character. Fine. So what we can do, like we were at state Q0, read the input symbol A, changed it, reached the state Q1, then change this symbol to say X, and the last one is the direction of the head, the direction of the read write head, that is either it is going on to the right direction or it is going on to the left direction. So I have to write say I can write L or R, whatever I need I can write it here. So that is your input part, this is your output part. So we are working on some state Q0, and we read input A, and then after reading the input A, we reach state Q1, and then change the input A to X, and the direction of the read write head is onto the left. So that means there is a transition function, how to transit from one state to another. Okay. Next one, Q0 belongs to Q. So Q0 again is a initial state, like in this one we have Q0. So Q0 is the initial state which actually belongs to Q. And the last one, F, is a subset of Q, is the set of final states. So we can have a set of final states that will be denoted with the capital letter F. Okay. So these are the 7 tuples of the Turing machine. Fine. Now why there is a requirement of Turing machine? So first of all, the first machine that we studied was finite automata, that was NFA or the DFA. But for certain languages the finite automata was getting failed, like it was not able to compare things. Okay. So for comparison, what we got another machine that was called as PDA. So PDA was able to compare things, like for the language A to the power n, B to the power n, the finite automata was not able to recognize this kind of string. Okay. So what we did, we got another machine that was called as PDA, and PDA was a combination of finite automata plus a stack. Okay. So what we do in that one, we are able to compare this A and B with the help of the stack in that. But there are some languages for which even this PDA is getting failed, like whenever there is only a single comparison needs to be done, we can use a PDA for this one. But whenever more than one comparison has to be done, the PDA is not able to do that. So suppose I give you a language A to the power n, B to the power n, C to the power n. Now in this one we have certain comparisons that needs to be done, that is A have to be compared with B, B has to be compared with C, or you can say B has to be compared with A, or C has to be compared with B, and C has to be compared with A. Okay. So more than one comparison has to be done in this one. So for this one the PDA is not capable of doing that. So for that purpose the concept of Turing machine came. In this one I can compare any number of characters in the strings. Okay. So in the next videos I'll design a Turing machine for this language also. Okay. Now we have certain representations of Turing machine. This is called as a transition table, and this is the transition diagram. Okay, so it is telling us how to move, how to transit from one state to another. So if you see this one, how to read this particular table, we have this present state and we have these tape symbols. The tape symbols we have are B, we have 0, we have 1. Okay, and the present state and the states that we have are Q1, Q2, Q3, Q4 and Q5, with Q1 as the initial state, Q5 as the final state. So how do we read this? To read this, what we do, suppose we are at state Q1, and at state Q1 we will make a transition from state Q1 to Q2, and the transition will be, the input will be B, this B will be changed to 1 and the direction of the read write head will be L. So how do we make this one? Suppose we have this one, so I'll make a state Q1 and I'll make a state Q2, and there is a movement from Q1 to Q2 and it is B, 1, L. So I'll write B, 1, L. So this is the transition. So Q1 is the initial state and we are moving from the initial state to the state Q2, and the input applied is B, B is changed to 1 and the direction of the read write head will be on the left side. Okay, similarly for this one, like we are moving from Q1 to Q1, so I'll make a self loop here, that is this one, self loop, and it is saying 0, 0, R. That is, on this self loop I'll write 0, 0, R. What does that mean? The current input is 0 and it is changed to 0 and the movement of the read write head will be on the right. So in this way we can make the transition diagram of this table, or this particular table. Now see this one, we have this transition diagram. This diagram is also of a Turing machine, and it is how to read this one. So we have the initial state as Q1, and at Q1 we are moving from Q1 to Q2, and what is this? It is the element to read, that is we are reading 0 in the input tape and we are changing the 0 to X, and the direction of the read write head will be on the right. Fine. So at Q2 what we are doing, we have a self loop, that is at Q2 we are reading the input symbol Y and we are changing it to Y only and moving on to the right direction. Similarly at Q2 I have one more transition to Q3 also, that is I am reading the input symbol 1 and changing it to Y, and the direction of the read write head will be on to the left side. Fine. Similarly on Q2 I again have one more transition, that is when I'm reading input symbol 0, it is changed to 0 and the read write head direction will be on to the right. Similarly at Q3 we have 1, 2 and 3 transitions from Q3, 1 to Q5, 1 to Q3 self and 1 to Q4. So in this way we read this particular Turing machine. Okay, suppose I give you some string, and the string in this case is 0, 0, 1, 1. So if you need to find out the computation sequence of this particular string on this particular machine, then how will you write the description of the states? So we'll start with Q1 and then we'll hop around the states and while reading the input string 0, 0, 1, 1, and finally I should read all these elements, and finally where I should go on to the final state Q6. So let's start doing this one. Find the computation sequence of the input string 0, 0, 1, 1. So we have B 0, 0, 1, 1. So what I told you, we have in the input tape we have unlimited infinite number of blank symbols. So I can place blanks onto the left hand side, I can place blanks onto the right hand side. So I'll place several blanks here, and currently the read write head is onto the first 0. So it is on 0 right now, first one. Okay, so I'm reading this 0 and the initial state is Q1. The first state is Q1. So at Q1 the input is 0. So at Q1 the input is 0. So whenever we are reading the 0, we are changing it to X and moving on to the right direction. Okay, so the next one is, I'll move on. So I'll get 0, X, R. That is where I'll go to state Q2. So I'll not write Q2 here. In fact, I'll write B 0, 0, 1, 1. And it is saying that this 0 should be changed to X. So I should change this 0 to X. So I'll remove this 0 from here and I will change it to X. And it is saying the direction of read write head will be on the right hand side. So that the read write head will be on to the next 0 and the state is currently Q2. Okay, similarly I'll do this for the next state. So at Q2 the input is 0, so at Q2 the input is 0, so we have this transition 0. Okay, so I'll apply for this one, that is on Q2 0 comma 0 comma R. What does that mean? We reach on to state Q2, and this means whenever you are reading the 0 you should leave it as 0 and move on to the right direction. So what I'll get, I'll write B, this X should be X only, 0 is 0 only, and then 1 1 B, and the read write head will shift to the next part, that is it will be shifting on to this one, and the state is, it is self loop, so it is a state Q2 only. Okay, now I'll do for the next one. So next one is at Q2 the input is 1, so at Q2 the input is 1, so we have this transition 1 y L, so it is 1 comma y comma L. It is saying that we have to change this 1 to y, and the read write head will now point the left part of the string, the left most element. Fine, so what I'll do, I'll write B here, this will be X, this will be 0, this 1 is changed to y, and there is 1, there is B, and the read write head was pointing on to this 1 earlier, now it will point to the left, that is onto the 0, and the state we are reaching is Q3. Okay, now again, so at Q3 input is 0, so at Q3 input is 0, we have this transition 0 0 L, so I'll write 0 comma 0 comma L here, and that is whenever we are at state Q3, whenever we are reading 0, we should leave it as 0 only and move to the left side. So I'll move on to the left side, that is B, X 0 should be 0 only, Y 1 B, earlier it was on 0, now it will come on to the left, that is on to this X, and the state will be Q4. Okay, so now next one is at Q4 the input is X, at Q4 the input is X, so we have this way, input is X, so I'll do this one, X comma R, and it is saying whenever we are reading this X you should change it to X only, so I'll change it to X only, B, X will be X only, 0 Y 1 B, and move to the right, so the pointer will now point onto this one, and the state is now Q1. Okay, now at Q1 input is 0, at Q1 input is 0, so I'll again change this 0 to X, so it will be 0 comma X comma R, so I'll change it now. So what I'll get B X, 0 will be changed to X, and then Y, and then 1, and then B, and this read write head will now move on to the next Y, that is the right part, so it will now point onto this Y, and the state is now, we are reaching out to state Q2. So at Q2 the input is Y, so at Q2 the input is Y, we have this transition. Okay, so Y Y R, so I'll write Y comma R, that is whenever we are reading Y on state Q2 you should leave it as Y only and move to the right hand side. So I'll write B X X, Y will be Y, then 1, then B, then Y will be Y, and I'll move on to the next one, and the state will be Q2 because it is a self loop. Okay, now at Q2 input for 1, so now at Q2 input for 1, so you have this transition 1 comma Y comma L, so I'll write 1 comma Y comma L, and that is 1 should be changed to Y this time, so I'll change this 1 to Y. So what I'll write B X X, then Y, this 1 is changed to Y and move to the left, so now the pointer will now move on to this Y, and the state will be where I'm going. So I was at earlier at state Q2, so at state Q2 input for 1, so at Q2 input for 1, so we are moving at state Q3, this will be our state Q3. Now at state Q3 input for Y, so at Q3 input for Y, we have Y comma L, so that is a self loop. So what I'll do, I'll write Y comma L, that is Y should be Y and move to the left side, that is I'll move on B X X, this Y, then again Y, it is B also, and then there is B, earlier it was on this Y, it will now come on to this X, and the state will be self loop, so will be Q3 only. Okay, So now at Q3, what I'll do, at Q3 input for X. So at Q3 input for X, again I have this move now. So I'll apply this one, X comma R, and it is saying this X should be X and move on to the right side. So I'll move on to the right side. What I'll write B, this X, and then X will be X only, Y, and then B, and move to the right. So it will now point on to this Y, and the state will be XXR. I'm moving on to state Q5 this time. Okay, so now at Q5 input for Y. So at Q5 input for Y, so I have this self loop. So I'll write Y comma R. That is, whenever at state Q5, whenever we are reading Y, we should leave it as Y and move to the right side. So I'll move on to the right side. What I'll write here, B, X, this Y will be Y, then B. The pointer will now point on to this one, and the state will be, it is a self loop, so it will be Q5 only. Okay, so now at Q5 input for Y, I have Y, that is the same one. So I'll apply Y comma R. It is saying whenever at Q5, whenever we are reading Y, it should be Y and move on to the right hand side. So I'll move on to the right hand side. What I'll write here, I'll write B, X, Y, B, and the pointer will now point onto this one, and the state will be Q5 only because it is a self loop. Okay, now at Q5 input for B, we have BBR. I'll write B comma R, and what I'll do, B, X, Y, B. I can write several B's here. I'll say this one is, I can write some more B's here. So it is saying B should be B and move on to the right hand side. So I'll move on to the right hand side, and B is B, and the state is Q6, which is your final state, and we are done. So this string 0011 is accepted by this Turing machine, and the computation sequence of 0011 is this thing. So we are starting from state Q1 and then moving around the states Q2, Q3, Q4, and finally we are terminating at state Q6. And after termination, we have seen that 0 has been changed to X and the 1 has been changed to Y in this case. So in the input symbol, if we have 0, 0 and 1, 1, so this 0, 0 has 1, 1 has been changed to X, X and Y, Y, and remaining we have B's in the input tape. Okay, so thank you so much.